Okay, x. Oh no, it's not an angle. I haven't done this in 3 days. It's gone. Okay, what's the first thing we should do? Label it. There's the hypotenuse. For this side, no, that's not what I want to do. Here's an angle. For this angle, this side is the opposite. So that must be the adjacent. Okay? Do I care about the hypotenuse here? No. Which one? I'm trying to find the opposite. I'm given the adjacent. What ratio is that? SOHCAHTOA, tangent. The tangent of 24 is opposite over adjacent. Okay? How do I solve this thing for x? Is that going to help me? I'm trying to solve this for x. I want to get rid of 68. Let's multiply both sides by 68. That swap is what we're going to do if we don't know the denominator. Okay? Here, you can think of that as cross multiplying. Actually, that's what we do when we swap anyway. Okay? 68 divided by 68. X is 68 times tangent of 24. Okay, I'm not going to plug that in my calculator. I got 30. Do I have units here? No. So it's 30 units. That's not degrees. I know it looks like an angle. That's a length, right? X is a length here. Does it look reasonable, kind of proportion to my question? Sure. But remember, you know, they're not always, does it say it here? No, it doesn't. I think it's the next lesson. It says pictures are not accurate. Well, that kind of looks like 24, maybe a bit big, okay? Just make sure, always look at your answer. Does it make sense, okay? 68 degrees, yeah. Okay, 30, sure, okay? Okay, x. Label your triangle. X is a what? It's a hypotenuse, okay? For this angle, 126 is the opposite. Adjacent, well, he's over there. I'm trying to find x. I'm trying to find a hypotenuse. I'm given an opposite. What formula has O and H in it? Sine, not sin. So the sine of 69 degrees is opposite over hypotenuse. Alicia? Let's swap it, okay? I'll show you again algebraically what we're doing, okay? X is on the bottom. I don't want him on the bottom, I want him on the top. So let's multiply both sides by x. X divided by x. Now he's over there. I want to get rid of sine 69, so I divide it from both sides, and x is 126 over the sine of 69 degrees. Okay? Algebraically, that's the correct way to do it. But remember, if I backtrack all that, if I just swap those, do I get the same thing? Yes, I do. Okay? So one way is the way to teach it the correct way, but the other way is I want to make sure you guys get the mark here. Okay? So if we just swap x, if it's a denominator, we're going to swap. Okay, let's say that. If it's a numerator, all I'm going to do is multiply both sides by 68, or just times these two. Okay? All right? If it's a denominator, we're dividing. If it's a numerator, we're multiplying. If you like memorizing, maybe that'll help. Okay, how do you put that in your calculator? Just like it looks. If you got a good one, and if you got a not a good calculator, well, good luck. Does that look right? Does it look reasonable? Okay, I was like, well, that doesn't look like an angle to me. I'm thinking of Math 11. Yeah, this is a length, right? We're finding the hypotenuse. Remember, it's always the longest side. That better be longer than 126. To the nearest whole number, that's 135. 5. Do I have units? No. It's 135 units, whatever that is. Okay? X. How do I find that? Label your triangle. Let me use a different color. That's the hypotenuse. This is the opposite. Doesn't look like I care about that. That's the adjacent. Which formula has A and H? Cosine. So the cosine of X equals A over H. When I'm trying to find the angle, what button am I pushing, Bailey? Yeah, okay. I know she knows what she means, but do you know that I know what she means? I don't know. Okay, so push the inverse button on your calculator. I got 56 degrees. Does it look reasonable for that angle? Sure. Okay, always kind of check your picture. Does it look like it makes sense? Okay, telephone pole. You guys know what this is? Yeah. Have you ever seen a telephone on top of one of these poles? Way back a long, long time ago, we actually could not speak on a phone unless it was connected with a wire. Can you believe that? Yeah. Okay. So to communicate with people, we had to put in this big, tall, cylindrical piece of wood known as a telephone pole. We connected all these wires, okay, so people could talk. I know. And while we're at it, we may as well like hook up some electricity, throw those on there too, just so they can, connect up their Xbox. Okay? Why don't we call these power poles? Like it'll come soon. There won't even be any landlines probably, right? I don't know, 10, 20 years. Why bother? It's all wireless. So why do we call it it'll still be called a telephone pole, right? Even though there's no telephone wires on there at all. Mark my words. Okay, this is 11 meters tall. It's supported by a wire, okay? I don't know if any of these are supported by wires because they're usually pretty strong if you stick them far enough in the earth. But if you plant a new tree, you want to do this, don't you? You want to connect a wire to it so it doesn't blow over. All right? So there's the ground, there's a wire, it's holding this thing up. This is 13 meters. Does my picture make sense? Is that the hypotenuse? Is it the longest side so far? Okay, always kind of look at your picture, make sure it makes sense. Do we put these things in at a right angle? We try to, because then we get as high as possible, right? Calculate to the nearest degree the angle between the wire and the ground. Is that up here? No. Okay? That's down, oh, I blew half my pole. That's down there. That's what I want to find. Okay? What ratio do I want to use, Mr. Watson? Well, what are you given? That's the hypotenuse. This is the opposite side. Which one has H and O? The sine of that angle is opposite over hypotenuse. Okay? When you don't know the angle, use the inverse button, 58 degrees. Okay, to the nearest degree is what we should get. All right? Part B, same question. Calculate the distance to the nearest tenth, that says, right? Tenth spot. Tenth of a meter between the point where the wire is fixed to the ground and the foot or bottom or base of the pole. You know what? This is the only distance we don't have here. So you shouldn't make a mistake, right? Okay, that's what I want to know. Let's call it D for distance. Let's do trig first. How can I find D? I know now this is 58 degrees. If I have, well, I got 3 pieces of the puzzle here. Do I want to use that 58 degrees? Well, remember I said, like, don't use stuff that you just determined because you might make a mistake. But that's the only way I can kind of get this distance if I have an angle there, right? I could use Pythagoras, so we'll check it that way, okay? So using trig, I have this angle I want to find. That's the adjacent side, right? Because that's the opposite. That's the hypotenuse. Do you like O and A, or do you like H and A? You got a choice. I think I like tangent today. Okay? If you want to use cosine, ca, that's perfectly all right. Okay? There's lots of ways to do this. The tan of 58 degrees is O over A, which I'm calling D the distance. Okay? If it's on the bottom and we're trying to solve for it, what's our little trick? Swap. D is 11 over tan 58 degrees. Okay? If you put that in your calculator, I should get to the nearest tenth 6.9. What's the unit? Meters. Does it look reasonable? Actually, it kind of doesn't, because I didn't really draw my picture that accurate. That looks like less than 45 degrees. But if I would have drawn that with a 58 degree, sure, that looks accurate. Okay, so I'm okay with that. And we're going to check it anyway. Okay? So Pythagoras, some of us are still a bit rusty. C is always the hypotenuse. This could be A or B. It doesn't matter. The Pythagorean relationship is C squared is A squared plus B squared. If I'm solving this for the hypotenuse, that's probably how I want my formula. But if I'm solving it for one of the legs, in this case this one, I probably want to write it in terms of this thing. A squared is the hypotenuse squared minus the other side squared. And this is what's on your formula sheet. It's in that form. It doesn't even say C squared is A squared plus B squared. Oh yeah, I'm sorry, yes it does. Scratch that. It says A squared plus, I know it just didn't look like that. It says A squared plus B squared is C squared. Okay? That's the same as this. That's what you're given. Okay? If you're trying to solve for one of the legs, write it like that. It's C squared minus B squared. Okay? Now how did you get that? Well, I went, let's get rid of this. Let's subtract B squared from both sides. So A squared is C squared minus B squared. Then A is D. What's C? 13. So 13 squared minus 11 squared. So D squared is 48. I want D, take the square root of both sides, and voila, what do I get? 6.9. Okay? I've done it two ways. Now I know for sure I'm pretty well got it. Don't forget, guys, you can check this stuff, right, on your test. Okay? Solving. When they say solve, that means find everything. Okay? Determine all angles and sides. You're only going to have three things to get. Like, look at this guy. There's one, there's two, and there's three. There's no other way you guys can do this. We have to give you at least two pieces of information, and it's always going to be a right angle. Okay, so there's three down, three to go. Where do we want to start? And there might be lots of choices. Okay, there's no right way or wrong way. It's all got to work, though. Let's start there. What is that angle? How many degrees are in a triangle? Does anyone know? 180 degrees in a triangle. That's 90 already. So these two have to add up to 90 degrees, right? So what's 90 minus 37? 53 degrees. 53 and 37 and 90 equals 180. Okay? What next? Well, I just got this, so you know what? Let's not use that. We could start here. For 37 degrees, that's the hypotenuse. This is the opposite. That's the adjacent. Let's find the adjacent side. What formula has A and H? Cosine of 37 is A over H. How do I solve this thing for A? Get rid of the 33 by multiplying it to both sides. Yeah, let's not get carried away with this flip thing I told you about, okay? So what's 33 times cos 37? 26 to the nearest whole number, okay? There, I was quick. 2 down, 1 to go. Do you want, what are 2 ways to find the opposite side? Someone said tangent, okay. Pythagoras, sure. Could I use this angle? Sure. But if you can, like I said, try to use stuff that's already given, okay? I probably want to use sine here, guys, because I'm given H. I want to find O. If you use something you've just determined, what if you made a mistake with that? Then this one's going to be wrong too, okay? So try to, if you can, use what's given. The sine of 37 is O over H. Multiply both sides by 33. Okay, and what is 33 times sine 37? 20. Okay, what would be a smart thing to do now? If this was a test or a quiz? Yeah, let's see if c squared is a squared plus b squared. What is 33 squared? 1089. Is that like 26 squared plus 20 squared? It better be. Whoop, that's not going to work. It's a little off. Why is it a little off? Because we rounded the numbers, but are we pretty confident this thing works? Okay. Check it. Could I check every single ratio here if I wanted to? Could I say that the tangent of 53 is 26 over 20? Sure. Could I go tangent of 37 is 20 over 33? Check that? Sure. Okay. Remember, some of you are going, what? Okay, remember, if I'm looking at this angle, that's not the adjacent. That's opposite. This is the adjacent. Okay. Check, check, check. Okay. If you got lots of time, make sure you get all the marks. Okay. Solve DEF. Same thing. I'm given 3 things. I've got 3 things to find. I got to find that, this, and this. Would you start with trigonometry, or would you start with Pythagoras? There's no right or wrong here. Okay? Let's do this. What's F? Angle F. What's the only ratio I can use here? This is hypotenuse. For F, that's the opposite. So that's the adjacent. Which one has O and A? So the tan of angle F is 5.3 over 4.9. Inverse tangent of 5.3 divided by 4.9. Bracket. Oh, I got 2 divides in there. Is that going to work? 47.2 2 degrees. Okay? What next? Doesn't matter. Let's get the other angle. What would be the shortcut? What's 180 minus 90 minus 47.2? 42.8. Okay? You know what? I'm not sure about that. Let's double check it. If I go the tangent of D, that's O over A. Is that going to work? Well, you're trusting I did it right. Don't trust I did it right. I'm just the teacher. I'm looking for 42.8 degrees. Bingo. Okay, could have done that way too. Let's do Pythagoras for H, because everybody loves that. Some of us need practice. That's another way of saying it. Okay? So 4.9 squared plus 5.3 squared is that what H is? That's H squared. How do I get H? Take the square root of H'm. That looks more like it matches my picture, right? 5.3, 4.9. Does that look like 52? I hope not, but some of you guys will write that down as an answer and go, yep, I'm happy. On to the next question. Okay, 7.2. Okay, there's one thing, there's two things, where's the other one? There's 3 things. Solved. Okay, found every piece of the puzzle. Is it? 1 to 7 and 9. Okay, tons of time to finish this thing off. I just got to show you something first with number 2, because nobody gets the wording of this question. It's really kind of screwy. Okay, if I was German. Okay, if I was writing a question, I'd make it a little better than this. A mine shaft which slopes at an angle of 19 to the horizontal. If I put that in there, depression, do we remember what that is? That's from the horizontal down, right? Okay, angle of elevation is from the horizontal up. So this is from the horizontal down. The only problem is, when you see the word hillside, you want to draw a hill, not a horizontal line. Okay, so let's change that and put into the ground. That should help us draw a better picture. Sorry, Calvin? Yes. Okay, terrible question, but I do like it because it's a word problem. Okay? And hopefully it's not in China, otherwise, you know, the likelihood of everyone dying in there is pretty great. All right? Oh, I didn't record that, did I?